Good evening, all of you.
Good evening, sir.
Good evening, sir.
First, deal with the capacitors assignment.
Oh, so 13.
16.
So 16, 1 and 2.
16, 18, and 20.
So 12.
18 and 20.
Oh, so question 20. Oh, sorry, sir.
The question 8 and 4.
7th.
So 17, 2.
14, 2.
When we start from the fourth problem, what is the potential difference between A and B? Not fair. Why this problem should be a doubt?
So I just wanted to ask that I got 3 equations and 3 variables, and it was a bit long. So is that the only way? I use nodal analysis.
3 ohms, 5.
So you missed a 2.5.
Did I miss something?
Yeah. Bottom right.
So 2.5 ohms next
So
to
that makes it a
Why?
Wheatstone bridge.
What?
It's just a Wheatstone bridge.
Where's the
There's
Wheatstone?
one thing.
Where's the Wheatstone?
It's not a Wheatstone.
2 by this, 2 by 3, 5 by
It is.
7.5. Does that
It's a
ratio
Wheatstone bridge.
Oh yeah. Okay.
Yes, sir, it's a Wheatstone bridge.
Arey.
Then remove this.
Okay, now it's very
So also 27. Forgot to say that.
Fourth one, can I get the board?
yes. Sir.
So 27.
20?
7.
No.
So
7.
add 11.
Pardon?
Can you also add 11? 11.
This is 6 ohms. This is 1 ohm, 3 ohms, 4 ohms, 12 ohms, 6 ohms. This is BA. Here you have a battery of E and 5.5 ohms. Drawing these circuits itself will consume time. Generally, if you people observe these sort of circuits, when it was a paper-based examination, was very easy. Now, for example, you will also face the same trouble in the examination. You will see the circuit on the screen and you have to redraw it on the paper. Directly on the screen, you will not be able to solve. This consumes time actually. But, well, that will be the case for everyone, so nothing to worry, it's relative competition. Now, he says VA minus VB is 4 volts. VA minus VB is 4 volts. VA minus VB is 4 volts. Fine, find the EMF of the battery. Not fair. Find the EMF of the battery. If I get the current in this, hey, why should this be a problem? 1 plus 3 is 4. I'll remove this and I'll make it KB cheating here. For me on the board, I'll rub it, I'll make 4 plus 1, 3. For you people on the paper, you'll have to redraw it. All you cannot do it in one place. So preferably use a pencil and eraser. Oh, I think now you are not permitted to take all that into the examination. They only give you. Okay. 4 and 4. are in parallel. Equivalent resistance is 2. Right? Now, can you find out the current? This is capital I. Take small I, capital I minus small I. Not a big deal. You are given already small I is 4, small I is 3. 12 into small I is 4. This is what is being given to you. I is 1 by 3. Small I is 1/3 of an ampere. Listen, this will also have same current. So I know the potential difference across this. So I know the potential difference across this. So will I get the current here? Don't even apply KVL. Have a look at this. You got the potential difference current as I by 3, Y by 3, 1 by 3 ampere. Same current passes through this. So what is the potential difference across this? 12 plus 6 into 1 by 3. This is 18 by 3, 6 volts. So what will be the potential difference across this 6 volts? That means in this 1 ampere of current, if 1 ampere and 1 by 3 is flowing, what will be the current I? 1 plus 1 by 3, 4 by 3 amperes, if my calculation is right. Once I know I, will it be difficult for you to calculate E? Technically, you don't need to apply KVL as well, but once you know I want to apply KVL for any one branch, it is a child's play. Tell me when I can rub the board.
So done.
Eighth problem is the biggest practical joke played with you people ever in the last 2 years. Last 2 years, there cannot be a bigger practical joke played with you people as far as the eighth problem is concerned. This is E3, this is E2, this is E1. Resistances are 3 ohms. Batteries have internal resistance of 3 ohms.
So never mind this question. I forgot the internal resistance.
Current in some branches are shown in the circuit, right? Have a look at it. This is 5 amperes, right? Find the EMF of the cell E3, right? 3 resistances, 3 ohm, 3 cells, even into internal resistance connected. Now have a look at it. You're telling me this is 3 amperes. 5 amperes is coming, 3 is coming here. That means 2 amperes will come into this. Now, what is more intriguing is you are giving me 6 amperes here. Watch out for this. This whole network, 3 is coming in, 6 is going out. That means 3 amperes should be coming in. Yes or no?
Yes.
You know 5 amperes, 3 comes here, 2 comes here. Right? Out of 2, 3 is going here. That means in this I should have 1 ampere. Now
So
tell
then-
me, is it yet difficult for you? So,
No, sir. Just no
No,
difference.
no.
11, he kept this way. right? One in this plane, one in this plane.
Yeah.
Make it flat. Make it flat. See the diagram after making it flat. The diagram will look this way, 11. This is R. This is A and D. You wanted the battery to be connected between these two. Potential difference between that is given. R and R. R and R. A, this is F, this is E, this is C. Potential difference between A and D is V. What will be the potential difference between F and C? Somewhere to F and C. Where is F? F and C. Am I right? He is asking you potential difference across F and C. Now we'll do one step of simplification. First of all, this circuit, you understood how I got from the circuit given in the diagram?
Yes, sir.
Now, R and R, can I remove this and make it to R?
Yeah.
Here R and R, can I make it to R?
Yeah.
Right, I'll keep 2R here so that it may look good for you. So D can be kept here, right? A can be kept here. It will look familiar to you, making you feel familiar with the circuit known to you.
Yes, sir.
So this one will we connect equidistant points like A के बाद B and E जो एक एक रेजिस्टर पा रहा है वो करके उनको जो रेजिस्टर करके वो हम करते थे. Can we do that?
फिर से बोलो.
जो पॉइंट्स इक्वल पोटेंशियल पे है मतलब फ्रॉम ए पे बैटरी कनेक्टेड है तो उससे एक एक जो दूर रेजिस्टर के बाद पॉइंट्स आता है वो क्लब करके उनके बीच वाले रेजिस्टर.
Listen, when you are taking identical number of resistors, make sure that both the branches are identical. Then same current passes into both of them. Only when same current passes after two resistances each, I will assume equipotential points. If you tell me something like this, I'll be in big time trouble. R, 2R, 3R. R and R. Now you tell me, after crossing two resistances each or after crossing one resistance each, these both are equipotential. Reason being, current
is different.
Only if current is the same, you count the number of resistors conveniently, go ahead and tell me both the points are equipotential. भाई साहब, यहाँ आपको current same दिख रहा है. This is I, this is capital I minus small I. Capital I minus small I. मुझे तो दूर दूर तक एक भी equipotential point दिखने का.
हाँ सर, sorry.
12th question. 12th question I am redrawing this way. Have a look at this carefully. I keep my hand on the top and I crush it. Actually, this is a very good question to my knowledge. D and A. This is B and C. This is E and F. Firstly, this is R by 5, 2R by 5, R by 5, R by 5. What is given only and nomenclature? This is R by 5. This is not given, this is not given, this is not given. First of all, I placed my hand on the top and I crushed it. I placed my hand on the top and I crushed it. Do you agree that this will be the diagram? Firstly,
Yes.
confirm that.
Yes.
Yes, sir.
Now he gives you, in this branch, if this current is I1, in this it is 2I1. That is what he's telling you. The current in this branch is 2 times this.
No, sir. It's 2 times DF का current, no?
Sorry, my bad. So take this as I2. B said current will come. Take this as I2. This is 2 times I.
Yes, sir.
Right? The current in the branch BF will be half of the current through BC. Current in BC will be 2 times the current in BF. Agreed?
Yes.
Yes, sir. You can write I1 as 3I2 also.
I1 as
3I2.
why?
Because that is the only one which is giving current to both of us.
So
Same thing now.
Obviously, what he means to say is applying KCL here. I will write that
Oh, yeah.
separately. I1 is equal to I2 plus 2I2, 3I2. He directly applied it. The incoming current will be equal to the outgoing current in that particular branch. Right? Now I take the current in this branch to be I3. So what will be the current in this branch? 2I1 plus I3.
I2.
Right?
So 2I2.
2I2. I don't know why I'm again going wrong with that. 2I2 plus I3. Right?
Yes, sir.
Now, this is I3. Fine. This is 2I1 plus I3. Have a look at it. I2 is equal to I2. Where did I write I2? I2 is equal to I2. Okay. You take this current as well as I3. I2 is equal to I3 plus I3. Incoming current is equal to the outgoing current. Here, have a look. We are making one small guess here. From here, incoming current from here till here. If this I2 is splitting into these two, these both are identical paths. 1, 2, 1, 2. Do you remember in a cube when the diagonally opposite points have taken from one point, if you are passing through two identical paths from here, one resistance of R by 5, another resistance of R by 5. From here, one resistance of R by 5, another resistance of R by 5. So this incoming current will split equal into these both branches. Suppose if somebody is not convinced about this logic, I have no problem. Don't take I3 and I3. Take I3 dash. You will apply KVL one additional equation and find out I3. Do you get this point? Because I already know the answer, I am conveniently telling you this will be I3, this will be I3. Because from here, this is passing through two identical resistors. But suppose I am not convinced. Take this to be I3 dash. एक और इक्वेशन ऑफ KVL अप्लाई करेंगे and I3 dash eliminate करेंगे. First KVL I will apply to the branch A.
So I have a doubt in the logic you just gave. So what about the current through EA for that trick you just said? Wouldn't
That
that
will go
also?
back. That will never go. See, that's the input. If current is coming in, incoming current will never go back to that. It will have to go this way. Higher to lower voltage potential, current will never go back into the input terminal.
So I know that's a, but wouldn't that it just doesn't feel right, like that symmetry thing you said.
Fine, I told you the alternative.
Okay.
So it's basically resolved.
Apply I3 dash. You'll have one more equation, one more KVL. Eliminate I3 dash. You will get I2 is equal to I3 and I3.
Okay, sir. Okay.
Fine. Now, apply KVL to A, B, F, C, D. A, B, F, C, D. It will be VA minus 3I2 into 2R by 5 minus I2 into R by 5 minus I3 into R by 5 minus 2I2 plus I3 into R by 5 is equal to 0. First loop. Second loop, apply to A, B, C, D. A, B, C, D. You will have VA minus 2R by 5 into 3I2 minus 2I2. One second, did I miss something? By the way, what did they ask in this question?
We want the resistance of CB. So
CD, R, perfect. This into R minus R by 5 into 2I2 plus I3 is equal to, sorry, VD. Here also it is VD. I think they gave you,
most of them.
fine.
So instead of this, so we
One
can
second,
just take.
can we complete this? Can we complete this?
Okay, sir.
Yeah. Now, you applied KVL to A, B, F, C, D and applied KVL to A, B, C. Now, VA minus VD, equate both of them. Bring VD, you will get whole of this to the right, whole of this to the right. Equate both of them. Will I get smaller in terms of capital R? Say
Yes, sir.
something. Now,
Yes, sir.
here comes the third point. What did you say in the start? Somebody said, I'm not convinced that the current will be equal. I2 is 2, I3 is not convinced. He says, I2 is equal to 2, I3 is not convinced. Then take I3, I3 dash. Fine. Now apply KVL to this loop. Third equation. Sorry, involve this. Apply KVL to this loop. So I3 dash आ जाएगा.
But
आएगा कि नहीं? हाँ या ना बोलो.
so we don't know the current in DE. How do we know the current
in
DE?
Obviously we know whatever incoming current.
So but what is the incoming?
We didn't assume incoming current is a point.
So yeah, sir. AE, we don't know what's the current from A to E, and then we cannot get DE for current.
We do not have the current there. Then is there any other loop involving this? Hey, you can do one thing. Apply KVL to this loop. You will get a relation between I3 and I2.
Yes, sir.
The current in this branch will be
I2 minus I3.
right.
Yes.
Right. Apply KVL to this loop. You will get a relation between I2 and I3. I2 minus I3 is the current in this branch. Ultimately, I don't need the current in this branch. I just need to know that I3 is I2 by 2.
Yes, sir.
I actually need a relation between I3 and I2. So apply KVL to this loop. The job will be done. Then you don't even need to know this particular branch, I3. Get the relation between I3 and I2. Now somebody was saying something in between below.
Sir, I was just saying that instead of writing such big equations for KVL, we could have just equated the potential difference across BC in two ways.
Across
Yes, so you get the right answer by that also.
BC potential difference you have taken. Okay.
Yes, sir. Equating for both those, like both the routes. So from BC and then BFC.
BSC, yes, कहाँ पर है?
BFF.
BFC. Fine, not an issue. That's what is applying KVL to this loop.
Sir.
If you are equating the potential difference across this and across this, implies you are applying KVL to this loop.
So you get the answer directly by that.
I'm just saying that.
But how do you know I2 and I3?
After knowing I2 and I3.
हाँ, naturally, वो तो करना पड़ेगा.
So I'm just saying.
After that, you are
instead of
telling me
writing
you will
this.
not apply KVL to A, B, F, C, D.
Yeah,
right?
yeah, sir.
I am okay with it.
Yes, sir.
I applied between A, B, F, C, D because they are telling you that input is given at A and output is taken as D.
Yes.
But fair enough, that appears simpler. You are applying directly KVL to this particular loop. Any loop of your choice here, I'm okay with. How much time on an average did you people take to solve this problem?
So I tried it 3 times. So in the third time, sir, I took I3 as I by 2, I2 by 2. But sir, that felt as a scam.
So around 5 minutes.
It's okay. Reasonable time. 5 minutes means you people are good at it. I'm happy. Very first time I tried this problem, it took me 10-15 minutes to solve this.
Yes, sir, you can rub the ball.
Yes.
Hey, 13th is quite easy. 2R, R, 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 R. R and R, 2R, did I miss any register? Whenever I do this, I keep counting the number of registers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hope I have drawn all registers. I'm bad at this. Really bad at it. But have a look. You can pick up this particular point, disconnect this temporarily and keep it this way. Pick up this particular point and keep it here. Pick up this particular point and keep it here. Am I bringing this resistance parallel to this? Observe this. Am I bringing, sorry, keep this junction as it is. When I pick up this point and keep it here, can I remove this resistor and tell you it is placed in parallel to this first point? Say something.
Yes, sir. Yes, sir.
Right. Now come to the second point. This, pick up this point and place it here. This is what something that they're playing with. Now this point I placed it here and permitted. Now R and R, I will pick it up and place it here as 2R.
So you can
Right.
place the bottom 2R also.
This is also 2R. Right. Now I have to do one more job. This point also I will have to place it here. Baki, I think you will be able to do.
Yes.
Should not be difficult after here, after this. Yet you have a trouble, let me. There is no junction here. That makes the problem simple.
So
I'll make it look this way. Have a look. This single R, I'll pull it out. Your job becomes much easier. I'll pull it out. this single arm, right? It should be connected till here, right? I make the junction like this. Now have a look at it. This is connected,
Yes, sir.
right? Now it will appear much more simpler. 2R and 2R are in parallel. Are you able to see that?
Yes, sir.
2R and 2R. When you are connecting this point here, 2R and 2R are in parallel. Next step will be your answer. फोर्टीन सेकंड बिट 14th में सेकंड बिट क्या है यार एक ही क्वेश्चन दिख रहा है मुझे
Sir, I think they mean the second 14.
The
There are two
second,
14s now.
there are duplicates of questions.
the duplicate 14th the one with gas and velocity
Yes, sir. Sir, we know the relation Q equal to delta U plus work, right? Sir, so if work is 60%
wait
of
you are
Q.
talking about a resistance coil wired to an external battery
Yes, sir, yes, sir. Yes.
क्या पूछ रहे हो
Sir, उसमें delta Q equal to
I
Q
square
equal delta U plus W, ना?
into 0.60 oh wow
Sir, here Q is I square R, right?
right
For the ideal gas.
obviously
Sir, then
but
and Q is
60% of
delta
it
U.
assume only 60% energy is utilized to do work by the gas neglect the work done
Sir,
by
so work
atmospheric
is
pressure
Sir, work is 60% of Q and Q is delta U plus work. So delta U will be 40% of Q.
Delta U is constant, temperature constant here.
They just
Zero.
mean
Sir,
that.
So,
They just mean that.
sir, how is it possible?
They mean that 60% of the work being done is actually being able to do the real.
So he's
60%
saying
of
कि
the
अगर
supplied
heat,
energy.
अरे धैर्य wait. So what Aditya is saying कि if I supply Q amount of heat through the resistor and the work done is only 60% of Q heat supplied, so then there's a balance that's left over, right? That will increase the internal energy. So temperature can't remain constant under
Yes,
that
sir.
temperature.
It could radiate that energy away, no?
So
मतलब,
listen,
sorry.
don't try to change the question. उसको जो चाहिए वो दे दो आप वो बाकी 40% के साथ आपको क्या लेना देना है यार वो 60% बोल रहे हैं that's an old JEE question
So
Sir, तो
what
उससे
if it goes
temperature
into
change होगा
volume
ना?
expansion? What if it goes into volume expansion, but we just don't have data, so we're not calculating it?
it can be many things some will say radiation but radiation के लिए scope is not there
Thermally insulated.
insulated cylinder है thermally insulated cylinder frictionless piston ideal gas current coil constant speed now the temperature of the gas not as remains unchanged temperature remains unchanged du is 0 whole of dq will go into work done
Sir, तो 60% कैसे होगा? वो 100% होगा.
अरे भाई साहब assume 60% energy utilized to do work by the gas वो 60% ही लेने के लिए बोल रहा है 100% क्यों ले लोगे
सर, तो बाकी 40% से टेम्परेचर इंक्रीज होगा ना?
अरे भाई टेम्परेचर कांस्टेंट बोल रहा है क्वेश्चन में तो जबरदस्ती इंक्रीज कर लोगे
सर, मतलब वही डाउट था कि
Sir, he's saying
देखो here it is written temperature unchanged
हाँ सर,
तो
वही
he's
डाउट
saying
था.
अगर I
contradict हो रहा
square
है.
R, so he's saying अगर I square RT का amount of heat like energy generate हो रहा है because of the coil, तो फिर मतलब वो बाकी एनर्जी किधर जा रहा है अगर 60% ही हीट और वर्क में मतलब
वो
Very true.
बाकी एनर्जी गया तेल लाने. He is asking you to take 60%, 60% ले लो.
Okay, sir, got it.
बाकी एनर्जी का तुझे क्या लेना देना है यार?
That's it, excited all the electrons.
अब कितना रिसर्च आप क्वेश्चन पर करोगे? वो डायरेक्टली बोल रहा है टेक 60% ऑफ द हीट एंड टेम्परेचर कांस्टेंट रखा है, du is 0. So dq is equal to dw. mgv is I square r. t क्यों नहीं लिया भाई साहब? आपने पावर लिया है. सिक्सटीन्थ क्वेश्चन, ध्यान से. 16th कौन सा 16th भाई साहब?
First and second are both. So the last.
16th, please read out the first line.
The first one is 6 resistors. 6 resistor each of resistance.
Okay, first one. The language is slightly deceptive. I draw the diagram, you will be able to do it ironically.
सर ये क्या बकवास है, हम लोग ने वो 2 वर्टाइसेस के बीच में बनाया था उसको, बैटरी को.
Aha. X plus E.
So, but they
So-
haven't mentioned the polarities of the battery also.
It doesn't matter.
You reverse it. Who asked you to take the same polarity? मैंने थोड़ी बोला.
It doesn't matter.
Achha.
Now listen. If I take this is X plus E. I'm taking this as 0. This will be E. Will I get the current in this particular branch?
Yeah.
E minus 0. I is E minus 0 by R. I know the current here, I know the current here. बाकी जो चाहिए आपको आ जाएगा इसके बाद.
So
बोलो.
So what I did was like I thought of symmetry. Like
Wait. ये समझ में आया.
So what I did was thought of symmetry and then saw that like current going and then two sides से opposite आता है and two sides से same side आता है. Like cutting it from one
Battery
side.
he kept it to different places which destroyed the cement. Only single battery अगर लगा हुआ होता तो cement नहीं.
So I am taking the symmetry from like taking the battery in the symmetric plane. I'm taking two symmetric planes 2 times.
That I'm unable to visualize. कल जब क्लास में हूँ डायग्राम ड्रॉ करके.
Okay.
After this hint, will you be able to complete the problem?
Yes.
Yes. So
Tetrahedron, hypothetically confusing words. When they use those words, they're playing with you people.
So 16, the second one was left.
So second one में, it's a very popular standard question. He'll tell you the elongation in the spring and the distance between the plates is the same. That is where students get confused.
so that was the weird part.
That's playing with words only. Here, they'll tell you this is X, right? And then he'll tell you again this is X. This will be Kx, this will be K. Right? So this distance is L plus X. L is the natural length of the spring. Elongation in the spring is X. So L plus X. So now X plus L plus X is equal to D because these two plates are fixed. So how much will you get X? D minus L by 3. Once you get elongation, you know this plate is in equilibrium. Kx is equal to Q square by 2A epsilon naught. Q is equal to CV epsilon naught A by X into E is E by 2. Am I right if I remember the question well? This is a standard which I regularly used to do in the class. So I remember the values. But then this time I thought I'll give it in the assignment instead of
So it's-
solving in the quiz.
So it's E only, not E
So
by
it's C. It's C.
So it's E only.
But then C becomes C by 2, so that's okay.
Okay.
Yeah.
Yeah.
C by 2. The most unworthy question of being in the assignment is the 18th question. It's actually nothing, playing very cheap trick by drawing curves. Remember when I was telling you to find equivalent capacitors, I told you don't draw curves, draw straight lines. If you draw curves, you cannot recognize series and parallel. Redraw that with straight lines, your job will be done ironically. By drawing curves, they're beating around the bush. It's like holding your nose from this side. Right? But yet, sometimes cheap tricks well played in the examination matters a lot.
So can you put 22 also on the board?
No,
Question 22.
no, it will cost you $5 5 years down the lane.
हाँ sir, भेज दूंगा.
Don't assume you can cheat on me.
Sir, 17th question.
Something कर रहा हूँ भाई, इसीलिए थोड़ा
आपने
सा
रब कर दिया sir.
This will be epsilon naught a by 2 by d, epsilon naught a by 4 by d, epsilon naught a by 8 by d. First of all, what is this based on? If I have two plates this way, I have positive charge on this, I'll have negative charge here. Only then the field inside this plate will become 0. If negative charge splits upwards, then the field inside this plate will not become 0. So your field will be confined to this region. Your capacitance will be dealing with only that part which is common.
Sir, then the left part won't be equipotential, right, throughout.
Why?
Like the positive charge, other positive charge is going on the other side.
Positive charge है ना यार. This positive and negative will give me 0 field here. 0 field implies equipotential. The reason because you people get this doubt, if you have not handled old LCR meters, today everything is solid state electronic devices. Once upon a time, there was a radio of this size. Radios were of this size, in which there was an LCR oscillation. LCR. We'll be dealing with LCR oscillation in the chapter EMI. In this LCR oscillation, the frequency of this oscillation is 1 by root LC. This will also be calculated. So how can you change the frequency of this oscillating circuit by changing C? How will you change the capacitance of that capacitor inside? By turning a knob. By turning a knob, capacitance कैसा change हो जाएगा? The plate inside is fixed. The plate outside is connected to a circular knob. You are holding the knob and you are slowly turning this plate. As you are turning this plate, the common area is changing.
Yes, sir.
Common area changes, capacitance will change.
Yes, sir.
Capacitance changes, the frequency of the oscillation of this LCR will change. This frequency, when it matches with the radio wave frequencies which are being transmitted by the All India Radio, your oscillating LCR meter will vibrate with maximum amplitude. It will absorb whole of the signal which we used to hear as radio stations. We used to operate those antique pieces. The radio used to be this heavy. Ask your parents if any of them have seen that in their childhood. They must have seen. This problem would have become easy for you. You haven't seen such type of systems working. Hence, it appears slightly weird.
So, but if we use the derivation, then when we calculate delta V and we put it as E delta R, and we use sigma by 2 epsilon naught, why won't we consider the area of the whole plate? Won't the uncommon area that won't have any charge, will that not have any charge?
क्या बोल रहे हैं? Uncommon
So,
area which won't have
matlab,
any charge, will it not have any charge?
yeah, so No, when I first said it, it didn't sound like a question, so I reframed it as a question. Will it not have any charge, the uncommon area?
What did I draw here?
But why will it not have any charge?
If
ये तो
it
बोला सर ये
carries
field
charge
होगी zero
here, how will
infinity.
the field here be zero?
Shield is 1.
Acha, okay, fine.
Right? Field here will be zero only if the charge is confined till here.
Yeah,
So this part will not have free charge.
yes.
Right? Now, summation of their in series. D by epsilon naught A 1 by 2 plus 1 by 2 square plus 1 by 2 to the power 4 so on. I think I don't need to solve this further. Can I rub the board? Eighteenth question, I'll redraw this, take it down and compare it with the diagram. C, to C, battery E, C, 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 this is C, this is C, C. Hope I didn't miss anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Draw the diagram, compare it with the diagram given. Cheap tricks, well played. The most unworthy question in the assignment, but it's okay. Part of the game. They can never make it more dirtier than this. So you can go confidently to the exam. कुछ तो बोलो, सब सो गए. What did you say in between? 21st बोले थे किसी ने.
No, sir, 22nd. So I just wanted to ask, can you use symmetry to simplify the circuit in any way?
Symmetry हो नहीं रहा है इसमें because of that 2C.
नहीं, because of fold the lower part to the upper part.
Okay.
And then it will be unbalanced reach from big. You have to apply KVL.
Okay, okay. Huh. Yes, I did that only when I didn't get the answer.
Hey, you will get the answer. You want me to do that?
No, no, sir, no, no.
This problem is lengthy. That's the only issue with this.
So is 21 also just this what you call KVL or nodal?
Nodal, yeah, 21 is nodal. That will be much easier with nodal than K.
Okay, so but even with nodal, the equations are quite bad. 4 aate hain.
In this, there are 5 if I am right. Anybody
And
who has a shortcut for this less than 5 equation?
We can use symmetry kind of.
ऐसा use करोगे? You
तो
are
So
इसमें
taking correctly
KVL
charge
यूज
on
किया
this
था
and this.
नहीं नहीं सब इसमें नोडल यूज किया था नोडल वर्क्स टू these
So
things.
But
why
काफी
can't
We
लंबा
still
है.
got a lot of
Even
equations.
nodal, have a look. This is A and B. You are connecting a battery between this. Equivalent capacitance पूछा कि क्या पूछा?
So
Equivalent capacitance. Each C is 15 microfarads, right? Now you are taking this as 0.
Take it anything.
Q is equal to CV. Take this as 100 volts. 15, 15, 15, 15, 15, 15, 15, and 15. Q is equal to CC. C equivalent is equal to Q by V. Q by V, V is 100. So this is 0, this is 100 volts. Am I right? I take this as X and take this as Y. What should I take this?
100 minus.
Alright? I take this as X
No,
and
sir, on
Y.
that. On
A
that.
Alright?
and B ले लो उसको A and B.
A and B. Am I right?
Yes.
A and B ले लिया मैं कुछ और बोलो ना यार एक expression.
so alpha and
So
beta?
PQ.
Sir, B is 100 minus.
So
So PQ.
P X naught Y naught. I'm smarter than you. एक
Yes.
symbol नहीं बता पाते.
Sir,
Now-
Y naught is 100 minus X. Symmetry.
This is 100 is 0. What? Y naught is 100. किसने बोला भाई?
100 minus X.
Y.
Sir, symmetry.
क्या symmetry? He's saying Y naught is 100 minus X. How is that?
Sir, 100 से 100 minus X 100 से 100 minus X कम होगा तो X मिलेगा जो 15 से जो जा रहा है. Similarly, अगर 0 से अगर हम 100 minus X नीचे जाएंगे तो फिर Y naught 100 minus X होगा.
तो शायद से सही बोल रहा है वो क्योंकि there were like some sums
sir, I
in
think using the
like
Basically,
वो
I
ऐसे-
think he's saying because charge same होगा.
essentially if you
I
reverse
asked
the
that one
polarity
more
then
time,
identical.
same charge. You said no.
कुछ कैपेसिटर में.
Why not? You are telling me
Sir,
it's
जो
100
leftmost
minus
और
X.
rightmost
One
sir, जो
second,
leftmost
wait. Let that boy tell me this logic once again, because last year also on the video lecture, one of the students told me that, which I discarded and I went ahead with this, add one extra equation, one extra variable, which we solved by default. But what this boy says, I remember having heard last year also. Could you say that again? You're telling me Y naught is 100 minus X. But from which side did you come? This is
sir,
zero.
the leftmost capacitor and the rightmost capacitor will have the same charge by symmetry.
These both.
Yes, sir.
Okay. So this is 100 minus X men. Okay, this will be 100 minus X.
Sir, similarly,
the logic.
X naught will be 100 minus Y.
By default, then X naught is 100 minus Y.
So what symmetry did he use here? I mean,
What
it
he
seems a
claims
bit
is,
random.
listen, charge on this and this will be the same. If charge on these two is the same, potential difference across this is 100 minus X. Potential difference across this also should be 100 minus X. 100 minus X minus 0. Right?
So, but if he can use symmetry about the vertical line down the center, why can't you use symmetry about a horizontal line, like through the center? I don't understand.
What horizontal? I don't see a horizontal line here.
So, about what is he using the symmetry?
Don't use the symmetry because I also not able to see symmetry there. I take y naught, x naught, and I solve.
So basically
But
it's similar. So in similar,
If you are able
this
to see that symmetry, use it. If not, and going by the right procedure, I'll take y naught and x naught. I'll have one more equation, two more additional equations, and I solved it traditionally that way.
Okay.
So I think so because in like basics when we did like it switches over like in the diagonally. So that's what he used. I think so.
I have a feeling what he used is slightly different. Listen, battery terminals, if you reverse, I'll put it this way. My feeling about what that boy thought. Reverse the battery terminals. Don't you think these both will again have the same charge?
Yeah, makes sense.
He must have used it. So what happens is this potential difference across this and this is the same. So if this is 100 minus x, this will be 100 minus x, and 0 will give me potential difference. But will that boy tell me how did he come to conclusion with 100 minus y?
Similarly, now again switching if then.
So the bottom right, so the bottom left 15 is another upper right 15. Same charge.
Okay. Now potential difference across this and this we took equal, which we have done previously in quite a few unbalanced weeks, don't we just? All of you listen 1 second. Fine. Symmetry is something which may not strike us in the examination or under pressure. Under those circumstances, see, if you are able to see that this is 100 minus x and 100 minus y, you have only two variables. I'm damn sure you will be able to solve it. Firstly, this statement, are you people okay with?
Yes, sir.
Now, let me solve it the longer way so that nobody will have a complaint. I will not assume this to be 100 minus x. I take this to be y naught. I take this to be x naught. Then nobody will have a complaint. Halaki procedure is slightly lengthy. Yes or no?
Yes, sir.
Right? Listen. Now, you are taking this to be positive, negative, positive, negative, positive, negative. Now, this will be negative, positive, negative, positive, negative, positive, negative, positive, positive, negative. Now, listen. First, I'll conserve the charge on these three plates. What is the charge here? Minus of, this is 100. 100 minus x into 15 plus of x minus y into 15 plus of x minus x naught into 15 should be equal to 0. Now 1, 2, 3, 4. Have a look at it. 1, 2, 3, 4. This is minus of x minus x naught into 15 plus of x naught minus y into 15 plus of x naught minus y naught into 15 plus x naught minus 0 into 15 should be equal to 0. Now 1, 2, 3, 4. This was negative. 1, 2, 3, 4. Right? Are you able to see this? 1, 2, 3, 4. Third equation. I have 4 variables. Total I need 4 equations. Can I get 1, 2, no, not that. 1, 2, did I miss something? One more equation I need. Which one? Third equation is this. Third equation is minus of 100 minus y into 15 plus of y minus y naught into 15 minus of y minus x naught into 15. These three and this. This have I taken? No. X minus y with a negative sign into 15 is 0. Now I have taken these 4. Do I have one more equation or not?
So shouldn't it be x naught minus y into 15?
Here,
Yes, sir.
this one. If I've gone wrong, x naught minus I need one more equation here.
So take the y naught per point.
Why not कहाँ पर है? Why not कहाँ पर
Bottom
है?
right.
Bottom right, bottom right.
Oh yeah, this one. 1, 2, 3, 4. Done. 4 equations, 4 variables. This is what I did previous years. But I have a feeling what this boy says is right, because last year also some students, last year, some students who were rankers in the top 100, they told me the same thing. They took this time, why not as 100 minus x, this as 100 minus y. I remember them telling that. I brushed it aside and I went ahead with 4 equations then. So this boy's logic, how he saw symmetry, I don't know. But my way of looking at symmetry, that is, if I reverse the polarity of the battery, yet these both would be in the same positions. So these both will have the same charge. So he took the same. If you are able to see that, nothing better than that. That saves time. 4 equations will come down to 2 equations. I would love that.
So sahi hoga wo, because like in HCV also, not for this chapter, but for like thermal conduction through a rod, there was a very similar question where you reverse the two junctions, and then initially the gradient is 100 degrees Celsius. So then over there 25 becomes 75 and 75 becomes 25 once you reverse the two.
And obviously, 4 equations are coming down to 2 equations means anytime we would love to do it.
So the middle capacitor is the center of symmetry in this case.
This one.
Yes, sir.
Okay. This is the center of symmetry. Obviously, yeah, they look alike from both sides. Fair enough.
No, it will be equal. The charge on it will be equal to the same as 100 minus 100 and x, 100 minus x wala, no?
Yeah. After simplifying, you will get that by default. See, that's a different issue. After simplifying, you are able to see that. So the next time when you are applying it, you will use it.
So and in question number 21 also it's the same thing only, right? Just nodal analysis on those 4 points.
Yeah,
A,
yeah,
B,
sir.
B, and F.
21 at least is a bit easier. I have.
So no, sir, even the simplification for that is really, really.
Yeah. 4 equations, 4 variables.
But I thought I was stupid or something because like the such ghatia methods were there, and then I was thinking like there'll be obviously some kind
There
of
should be some
shortcut.
shortcut is the
Yeah,
first
yeah.
key.
So I gave up in the sheet, sir. After question number 22, I just left the sheet. I was like, मैं इतना घटिया से simplifications नहीं करने वाला हूँ. अच्छे methods नहीं strike हो रहे हैं तो फिर there's no point.
Tomorrow's class remind me once. Today I thought I'll tell you people. CR circuits में there was one alternate procedure given by one of the student in Andheri. I liked it. Remind me once, I'll explain that in tomorrow's class.
So have such questions come in tests? 4 equations, 4
It's
variables.
only troubling student, that's all. Just passing you through tough terrain. If such type of question come, if you are able to see the symmetry and decrease it to 2 equations and 2 variables, then solve it. If not, keep it till that. 4 equations बैठ के simplify करोगे 4 mark के लिए, I won't really suggest.
Okay.
Unless you agree that the numbers given are very comfortable. Remember that. The numbers given are
साथ ही
very
pressure में like the chances of getting it wrong are very, very high. 4 equations में बहुत ज़्यादा chance रहता है to mess up.
And then simplifying it also.
It's long, undoubtedly.
So then just one negative
Depends on
sign.
number of marks. Integer type में दिया है ज़्यादा mark दिया तो कर लूँगा भाई. क्यों नहीं करेंगे?
So, and in the end, after calculating all the 4 values, so just when you're using Q equal to CV, you can take it at either of the endpoints, right, to calculate Q?
Any of the endpoints, net total charge from this side or net total charge from this side.
Yes.
Either way, Q will become.
Then Q equal to CV.
Then you people said 27. Hey, 27 is a good one. Easy one. Actually. One capacitor here, one battery here, one capacitor. This is 3 microfarads This is 5 microfarads. This is 5 volts. You have one capacitance.
So it is 6
here.
microfarads.
Pardon? 6 microfarads. Perfect. 3 microfarads. There is a switch. There is a battery. This is 10 volts, 3 microfarads, 6 microfarads, 0, 5 volts, 6 microfarads, 5 volts, 5 volts, 10 volts. Initially, switch is open. Am I right? I'm taking this to be 0. Initially, can I claim that this plate, this plate, this plate are mutually connected and isolated? Initial charge on them is 0. First tell me yes or no. Which plate? This plate, this plate, and this plate. There is a battery in between, Noya. Yes, there is a battery.
So, sir,
Five
for
volts.
a battery doesn't produce charge.
Pardon?
Battery doesn't produce charge. For
Right. So this plate, this plate, this plate are mutually connected and isolated. Initial charge on them is 0 when the switch is open. Agreed?
Yes.
Yes, sir.
Now I close the switch.
so, just one thing I had a doubt on. Sir, is the charge individually on each of them 0 or like
No, all three put together. All
okay.
three put together. They're isolated. Right? Now that I close the switch, this is 0. How much will this be? 5 volt?
Yeah.
I take this to be X, this will be X, this will be X, this will be X. If this is 5 volts, this will be 5 volts. I hope I'm not missing anything. This will be 5 volts. How much will this be? 0 volts. Do you agree with that? If this is 0, this will be 6 volts or 5 volts. Fine. This will be 5. This will be 5. So this will be 5. So if this is 5, this will be how much? 15 volt. You understood why this is 5? If this is 0, this is 5. This is 5, this is 5, this is 5. So this will be 5, this will be 15. This is 5. So far, so good. Yes or no? Say something.
Yes.
Yes, sir.
Now, can you find out the charge on this, this, and this? ऐसा बड़ा आसानी से आ जाएगा. Isn't it? What will be the charge here? X minus 10. Why I needed it on. Can you find out the charge on these three capacitors now?
Yes, sir.
Yes, sir.
Right? Once you get the charge, you know the initial charge on all these three plates was 0. Now the charge on all the three plates put together, kitna dekh lo. So much charge has flown through the switch. That's the only possible way.
I was taking
The only possible way for the charge to reach these three plates is start flowing through this.
Yes, sir.
So now find the final charge on these three capacitors. You know the charge on these three plates. Initial charge before closing the switch is 0. Final charge after closing the switch on these three plates put together will not be difficult for you. Here, ये तो direct आ जाएगा आपको यहीं पर. This is 15, this is 5. Potential difference is 10. This will have 60 plus minus 60 microcoulombs. Right? If you can find out X, how do you want me to get X? Charge on this plate, and this plate should remain conserved. Find out
Yes.
X. Once you get X, you'll get the potential difference across this. If I'm right, you'll get X is equal to 4 volts if I remember well. I'll have this positive, this negative. So this will be how much? 4 3 12 microcoulombs. Now if this is 4 volts, this will be positive, this will be negative. Right? This will be 3 microcoulombs. So plus 3 microcoulomb minus 12 microcoulomb minus 60 microcoulomb minus 60 microcoulomb minus 12 microcoulomb plus 3 microcoulomb is the present charge on these three plates. What was the initial charge? 0. Difference is the charge which has flowed through this particular switch.
Okay.
So I have a general question. In capacitors, like if they ask for equivalent capacitance, how can we use symmetry in those cases? What symmetry? I don't understand because whenever I tried symmetry in this sheet, it didn't work. So like in question 20, if why isn't it symmetrical about the line joining the diagonally opposite points?
You'll have to go through whole of the lecture of symmetry on the YouTube. Symmetry in detail
Fine.
explain. It's a
I'll-
complete
Once
free
listen.
algebra job.
What?
Once call me after class, I'll explain.
Fine.
Right. It doesn't make sense also. The statement which you're telling me doesn't make sense to me. Right. Resistor में symmetry दिख रहा है, capacitor में नहीं दिख रहा है, तो मैं क्या बोलूं यार अब?
Okay.
चलो, see you people in tomorrow's class.